The fourth learning objective is EAR, effective annual rate and compounding. Now, banks are required by Truth in Lending Act to disclose to you the APR, but you'll find out that with a little math, that's not what you're actually paying. You're actually paying the effective annual rate. So when these things are compounded more than annually, compounded daily, compounded quarterly, compounded twice a year, biannually, if it says compounding blank, you want to calculate the effective annual rate. So you will get a stated rate or a quoted rate from the bank. They're required by law to tell you that APR, but then in the fine print it will say, like I said, compounded daily, compounded monthly, compounded quarterly, and you know that if it's a credit card, you're actually paying more than that amount. The EAR is in effect if the compound interest during the year, if it only happened once per year. So you're going to use the EAR whenever you see the words in a problem on the back of your credit card statement, compounded blank, compounded daily, compounded monthly, compounded annually, or not annually, but compounded annually, M is equal to 1, you don't need to do anything. But compounded quarterly, compounded monthly, you must calculate the EAR to see really what you're paying. So the formula is the EAR is equal to 1 plus whatever that quoted rate is, or the APR, over M being the number of compounding periods, all of that to the nth power minus 1, and pay close attention to your PEMDAS. If you put $100 in an account, how much will you have at the end of 1 year? 12% compounded quarterly. So in this case, M equals 4. And we know the answer is going to be higher than 12%. So quoted rate, QR is 12%, M is 4. Putting $100 in today, and number of years is 2 years. So we're going to use two things. We're going to use the EAR to calculate the effective annual rate first, and it's going to be higher than 12% because it's compounded quarterly. Then we're going to plug that higher rate into the future value equation to see what I'll have at the end of 2 years. So 1 plus quantity 0.12 over 4 to the fourth power minus 1, I'm really getting 12.55%, not 12%, because it's compounded quarterly. And then I plug the 12.55% into the future value equation from Chapter 5, and I see that I'm going to end up with $126.68. So EAR will be used in this case whenever it says the words compounded quarterly. Here are 3 banks. Which bank gives you the best deal? Is it 15% compounded daily, 15.5% compounded quarterly, or 16% compounded annually? Which of these 3 banks should you invest your money in? That's the APR, annual percentage rate. You need to calculate the EAR because they're compounded more than once per year. So in the first one, M equals 365. In the second bank, M equals 4. And at the third bank, M equals 1 because it's compounded annually. You don't even really need to do the EAR. The effective annual rate for Bank A is 16.18%. The effective annual rate for Bank B is 16.42%. And at Bank C, it's 16% because it's compounded only once per year. And again, if I'm going to invest my money, I'm going to invest in Bank B, which pays me the higher effective annual rate. Again, use EAR whenever you see these words compounded daily, compounded quarterly, compounded monthly. If it was monthly, M would equal 12. Bank B, again, is the best bank for investing. It's going to give you the highest EAR. APR is required by law. This is what the bank will quote you or state to you. You need to calculate the EAR if you see the word compounded monthly. Here's another example. You may have a credit card in your own wallet that quotes a rate, an APR of 18%. That's not uncommon. What's the actual rate you're paying if it's compounded monthly? Monthly payments are required. So the EAR is 1 plus quantity 0.18 over 12 to the 12th power minus 1. So you're really paying a whopping 19.5%, 19.56% on that credit card that you thought you were paying 18% on. That's because the bank only is required to give you an APR, a quoted rate or a stated rate. If you want to compound continuously, you could put a very, very large number in for M, The graph will still look like this. The other way to calculate that is to go e to the q, where q is the quoted rate. So the EAR is e to the q minus 1. And you can see from the graph it's an exponential curve, increasing exponentially. As you go continuously, that will be the highest of the m's, if you will.